All right, so here is your second video to watch while I am out. This section is all about complex numbers, and we're not going to go super in depth to complex numbers for the purposes of this class, but it is something that you're going to see a ton of in college algebra. So I want to at least introduce you to the basics so that it's not super brand new when you see it again in the future. Okay, complex numbers. Are numbers that we have basically created to make our lives more easy. Okay, complex numbers are different in that they have an imaginary unit. Okay, so we have an imaginary unit which we have called I. I'm sure short for imaginary, right? And we have defined I to equal the square root of -1. Now that kind of seems like a strange thing to define I as, but here's why we care. Here's why we need this square root of a -1. Because when we've done all the radicals we've been doing, if we ever came in contact with something like the square root of -25, this is actually something that we are not capable of simplifying, right? This, we can't say it equals 5, right? Because 5 times 5 is +25. So that doesn't work. And we can't say it equals -5 because -5 times -5 equals +25. So when we're dealing with square roots, there's no way to have two copies of any given number and multiply them together and come out with a negative, right? Because a positive times positive is positive and a negative times negative is positive. So this is not possible. So this, all we could ever say is this is not a real number. We couldn't simplify it. So we went ahead and created I and said, let's let I be the square root of -1. That way, anytime we get a negative under the radical, we can just pull that negative out and write an I outside of the radical. So I'm just going to go ahead and write, we're going to need I to pull the negative out. Okay, so that's why we care about I. That's what we're going to do with I. One other thing that you need to be sure and know about I is we need to not only know what I is, but we need to know what I squared is. So let's think about this for a second. If I equals the square root of -1, what would happen if I square both sides of this? I would get I squared on the left, and on the right I would get the square root of -1 squared. Now, just like a square root undoes a square will undo a square root. So basically my square and my square root cancel here, and that tells me that I squared is equal to -1. Now what's important about this is if we know what I is and we know what I squared is, we should never have any higher power of I. Because any higher power of I, we can simplify down to either equaling -1 or to just be able to be written as I to the first power. So if you are a highlighter, these are two things that you need to make sure you remember. You need to know what I equals and you need to know what I squared equals. So let's go ahead and look at just simplifying some problems using what we know about I. So if I ask you to simplify the square root of -90, the first thing we do before anything else is we address this negative. So I'm going to go ahead and pull that out as an I. So I'm just going to rewrite this as I square root of 90. So just get that negative out of there. Now that the negative's gone, we can go ahead and address the square root of 90 the same way we did on all the other lessons we've done so far with radicals. So I can go ahead and break this down. 90, I don't know, it ends in a 0, so I know 5 goes into it. So 5 goes into 90 18 times. 18 is 2 times 9, and 9 is 3 times 3. So I have 2 copies of a 3, so I can bring a 3 out, and notice I'm left with a 2 and I'm left with a 5. So bringing out a 3, left with a 2 and a 5 underneath, which means I get 3i square root of 10, right? I brought out the I. Oops, I forgot to put my I here. I brought out the I to get rid of the negative. I brought out the 3 because I have 2 copies, so 3 and I are written out front, and I'm left with a 5 and 2 underneath, so I just multiply them back together to get square root of 10. Now in Knewton, it will accept answers like this, which is how I prefer to have them written. It will also allow you, when you pull out the I, to write the I at the back. So you can also write this as 3 square root of 10i. Now the reason I don't prefer this is because what happens is a lot of students make the square root of 10 and they just type I in at the end, and it actually puts that I under the radical, which is not correct. So I prefer that you write the I in front of the radical, but if you insist on writing it at the end of the radical, make sure that I is not under the radical. Make sure it's outside the radical, okay? All right, so let's look at another one. Let's look at the square root of negative 117. So before I start doing anything, I want to make sure I take that negative out of the radical. So that gives me my I take out the I, and now I can address the square root of 117. Now 117 is not even, right? So 2 doesn't go into it. So I want to check and see if 3 goes into it. You can use your calculator, or a shortcut method that I learned a long time ago is to see if a number is divisible by 3, you just add all the numbers together. So 1 and 1 is 2, 2 and 7 is 9. Since 3 goes into 9, 3 will go into this number. So 3 goes into 117 39 times. And then 39, pretty obviously, is divisible by 3. And it goes 13 times. And then 13 is prime, so I can't go further with that. So notice I have 2 copies of a 3 that I can pull out, and a 13 that's going to be left under the radical. So I have the 3 that I pulled out, I have the I that I pulled out, and the only thing that's left under my radical is my square root of 13. Okay. All right, so that's pretty much the extent of simplifying radicals with complex numbers. Is make sure you pull out the negative first, and then once you pull out the negative, this is exactly like the radicals we've done on our other sections. So the last thing I want to talk about is those higher power of i's. Okay, so I'm going to go ahead and just write a little note down here and say, because I squared equals negative 1, we should only ever have a solution with the first power of I. Okay, because we can simplify any power of I that is 2 or greater, our answers should only ever have the first power of I in them. So what I want to do is I just want to take you through the thought process on how you can take I to some ridiculously large power and simplify it down to an answer that either has only an I to the first power or that may not even have an I. So let's look at an example. Let's take an easy one. Let's look at like I to the third power. Okay. So what I want to do is I want to know how many I squareds do I have inside an I cubed, right? And the reason I want to know that is because I can replace I squared with negative 1. So I'm going to go ahead and just write it out so you can see it on this first one, and then we won't write this much information on all of them. So I cubed is I times I times I, right? It's 3 copies of I. So I can see here, here's an I squared. So I could rewrite this actually as I squared times I, right? 3 is the same as 2 plus 1, right? I have 2 copies here and 1 copy here. And then once I have it written this way, I can just replace my I squared, because I know I squared is equal to negative 1. So this becomes negative 1 times I. And negative 1 times I is just negative I. So we took something that was a higher power of I and was able to simplify it down to just negative I. So this is the idea. Now, I don't want to have to write out all these, because what if I had something like I to the 213th power, right? I don't want to write out 213 i's and circle every two of them. So I'm going to use that idea of kind of like we did when we were simplifying radicals and we divided, the square, like 2 goes into 3 how many times, how many come out, how many's left over. We're going to do the same thing here. So let's look at another example. Let's look at I to the 13th power. Okay, so I want to know how many I squareds, or how many copies of 2 do I have in 13? So to figure that out, I'm just going to divide. 2 goes into 13 how many times? Well, 2 goes into 13 6 times. 6 times 2 is 12, and I have 1 left over. So what this is telling me, the reason I divided this number by 2 is I wanted to know how many copies of I squared do I have? And I got 6. So this means I have 6 copies of I squared. And this is how many leftover i's I have. Okay? So I can rewrite this now. I know I have 6 copies of I squared. So I'm just going to write I squared to the 6th power, because I have 6 copies of I squared. Does that make sense? And then I have 1 leftover I. So I'm going to write my I there. Now, just like I did on this last problem, we know what I squared equals. I squared equals negative 1. So this is negative 1, right? Just rewriting it, but with a negative 1 to the 6th power times I. Now, negative 1 to the 6th power, that means I have 6 copies of I squared, right? Or sorry, not I squared. I have 6 copies of negative 1. So negative 1 times 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 negative 1. If I have 6 copies, that's an even number of copies. So you can either do this in your calculator, or we can just use the idea that if I have an even number of negatives, that's going to turn out positive. So this really just ends up being positive 1 times I, and positive 1 times I is just I. So we took something horrible like I to the 13th, and we were able to manipulate it so that we get down to something with just the first power of I. Okay, I'm going to show you one more just so that you see it one more time, and then I'll give y'all some to practice. Okay, so let's look at I to the 88th power. So obviously we don't want to take I and write out 88 copies of I and try to circle groupings of 2. Like that's bananas, right? So we're going to go ahead and use this idea of long division. I want to know within I to the 88, how many I squareds do I have? So I'm going to take 2, because that gives me my I squared, right? 2 goes into 88 how many times? Well, let's see. 2 goes into 8 4 times. 4 times 2 is 8, right? And then 2 goes into 8 4 times. So 2 goes into 88 44 times, right? And it goes in evenly. So that means I have 0 leftover i's, right? I have 44 copies of I squared. So that's how I'm going to write it. I squared to the 44th power, because I have 44 copies of I squared. And if you ever wonder if you wrote this right, you can just use your exponent rules to make sure it's the same. Remember, when we have a power raised to a power, we multiply. So 44 times 2 is 88, and that's what we started with. All right, and then we just replace our I squared. So this gives me negative 1 to the 44th power, right? Now again, you can plug this into your calculator and do negative 1 to the 44th power, or you can just think about, I have an even number of copies. If I have an even number of negatives, when I multiply those all together, it should give me a positive. So this just becomes positive 1, and I don't even have an I. Okay, kind of neat. So what you're doing is you're hoping to replace I squared with -1. To figure out how many I squareds you have, you just do 2 divided into whatever your exponent is. That tells you how many copies of I squared you have and how many leftover I's you have. Then you should be able to simplify. So what I'm going to do is I'm going to give y'all several problems to practice, and that way y'all can work it, and if you have any questions, be able to ask Brittany for some help if you're watching this video during class time. Okay, so here are your practice problems. All right, so go ahead and pause the video and work these out. If you have questions, let Brittany know. Otherwise, once you get done with them, go ahead and play the video, and I'll show them to you all worked out. Okay? All right, so on number 1, first thing we do always is pull out the I. Once we take that negative and pull it out as an I, then we can simplify the radical. So 27 is 3 times 9. 9 is 3 times 3. I have 2 copies of the 3, so that 3 comes out with my I. And then I have 1 3 left over, so it stays under the radical. On number 2, same thing. First thing I do is bring out that negative as an I. So I have I square root of 75. And then I can break down this 75. It ends in a 5, so I know 5 goes into it. 5 goes into 75 15 times. 15 is 5 times 3. I have 2 copies of a 5, so I can bring out the 5. So I have 5I that I've brought out, and that 3 that's left over stays under my radical. Okay. Number 3, I have the square root of -98. So I take that negative that's in front of that's under my radical, and I write it out front as an I. I square root of 98 simplifies down to 2 times 49, and 49 is 2 times 2. Or sorry, not 2 times 2. Just kidding. 7 times 7. And since I have 2 copies of a 7, I can bring out a 7 with my I, and the 2 that's left over stays under the radical. Okay. And then on the next 4 problems, we're just simplifying powers of I. So I to the 8th, I want to know how many copies of I squared can I get out of I to the 8th. So I just divide that exponent by 2. 2 goes into 8 4 times. That means I have 4 copies of I squared. And notice 2 goes into 8 4 times evenly, right? I have no leftovers. So I just have I squared to the 4th power. I squared is -1. -1 to the 4th power is +1. Number 5, I to the 66. Again, I'm trying to figure out how many I squareds do I have in 66. So 2 goes into 66 33 times, and it goes in evenly. So I have no leftover I's. So this tells me I have 33 copies of I squared. So I can write that as I squared to the 33rd power. Remember, I squared is -1. -1 to the 33rd power means I have an odd number of negatives. If I have an odd number of negatives, it's going to turn out negative. So I get -1. Number 6, I have I to the 53rd power. Again, I want to break it up into I squared, so I divide 53 by 2. 2 goes into 53 26 times with 1 left over. So that means I squared is going to be raised to the 26th power, because I have 26 copies of I squared, times that leftover I. Okay, I squared is -1. -1 to the 26th power, that's an even number. So if I have an even number of negatives, it makes it positive, times the 1 I have left over just leaves, or sorry, the I have left over leaves me with just I. And then number 7, I have 15 I's. I want to know how many I squareds I can get out of that. So I divide 15 by 2. 2 goes into 15 7 times with 1 left over. So that means I have 7 copies of I squared and 1 I left over. So I squared to the 7th times I. I squared is -1. -1 to the 7th power, that's an odd number. So an odd number is going to make this stay negative. So -1 times I leaves me with a -I. So notice these are all the possibilities. When you simplify any power of I, this is the only thing you should be able to get. A positive one, a negative one, a positive I, or a negative I. You should never have an I squared or any higher power of I in your solution. Okay, because if so, you haven't simplified all the way, because it should simplify all the way down to either something without an I or something with just the first power of I. Okay. All right, so that is the end of the basics of complex numbers. So both of these, let's see, the first one, yeah, so both of these assignments will be due next Wednesday. And next Wednesday, I believe, is when your next quiz is. So make sure that you get these homeworks finished by then so you can use your time wisely working on the next quiz prep assignment. If you have any questions, feel free to email me or ask Brittany in class. All right, we'll see y'all on Monday.